Hello, everyone, and welcome to the 35th episode of TechLifeSkills with Tanmay. My name is Tanmay Bakshi. Thank you very much for joining me today. And as you know, I love the TechLifeSkills series because through the series, I can share my and especially my guests' thoughts on a wide range of different topics relating to technology. And today, we're going to be going deeper into some of the lower level parts of technology, specifically the kinds that maybe as consumers we don't necessarily think about every day. Um, but the thing is that these technologies power so many of the experiences that we know and love. And specifically, we're going to be talking about the world of high performance computing. And around it, how infrastructure like Linux containers enable next generation HPC, and how all of that fits into a cloud strategy. And we're being joined today by a very special guest that I'm excited to talk to, Leo Reiter. Now, he is the CTO and SVP for Product at Nimbix. And Nimbix is a company doing cutting edge work to bring HPC to the cloud. They have pioneered a lot of the different technology that we take for granted today. And earlier this year, I had the honor of hosting their CEO, my mentor Steve Hebert, here in Toronto for the second episode of Tech Time with Tanmay. And so I will be linking to that in the live chat now, if you'd like to take a look at that after this episode as well. But now, without any further ado, I would love to welcome Leo to the show. Hi, Leo. How are you?
Hi, Tammy. How are you? Thanks for having me on the show.
I'm very well. Thank you very much for agreeing to be on. It's going to be a really exciting discussion, I'm sure. Now, before we get deeper into this world of technology, of course, I'm sure that everyone on the stream would love to know a little bit more about you and the work that you do. So would you like to maybe quickly introduce yourself?
I'd love to, yeah. So my name is Leo Reiter. At Nimbix, I'm actually responsible for both R&D as well as product. So I have product development, but I also have some interesting stuff like working directly with some of our larger customers, understanding what their use cases are, how we can solve their problems, and then relaying that back into the product development strategy. I've been at Nimbix for 7 years, just over 7 years, and prior to that, I've been in server-based computing my entire career, starting in the 90s. I've done everything from HPC now to end user computing, kind of the early pioneering technologies of cloud, virtual desktops, and then spent quite a bit of time in telecom as well. So in terms of large scale systems, things that, as you mentioned, we don't even think about when we consume technology, but they actually do power the world, right? So everything back to kind of the emergence of the internet. So anyway, I'm really happy to be here and really excited about the content today because I do think that it is a bit hidden for a lot of people, but it's also kind of front of mind for developers looking to get into cloud without having to kind of relearn all their technologies from that they're already familiar with. So.
Right. I feel like one thing that as consumers maybe we don't realize is that so many of the experiences that we love, right? Like, I mean, think about our computers and our laptops, right? These experiences, fundamentally, all of this innovation on the top that we see has to stem from innovation at the bottom of the stack, right? Maybe there are lots of different examples nowadays. How, for example, in gaming, because AMD makes the CPUs and GPUs, they can have really nice integration, giving you better gaming performance than, for example, Intel and Nvidia on their own. Or how switching not just instruction sets but also just designing chips, Apple themselves, they can provide better Macs to you as a user than you could have ever gotten with Intel, right? These are fundamental, very low level changes that then sort of innovation goes up the stack until consumers hit that point where they're like, oh yeah, this is a great new experience for me. Today though, we're going to talk a little bit more about that sort of back end and that low level technology. And specifically, I want to start off on the end of containerization. And I feel like that's been a really interesting area for me because when I started working with technology, this was just something that already existed and it was almost like a standard tool at the time. And I started using it and I was like, hey, this is great. How did developers live without this? So I do want to know a little bit more about this sort of history. So would you mind telling me a little bit more about what these Linux containers first of all are and what they enable us to do, and also where they came from? How did that sort of process of building these things even start?
Yeah, let me address your first question first, because if you can imagine, if you imagine the world as it is today, but without containers, then it's a very fair question to ask, how did we ever get this stuff done in the past? But if you go back, 10, 15, 20, 25 years ago, and probably more to the 20, 25 year ago range, you didn't have a lot. So today, you know, as a developer, you kind of build on top of frameworks. So, you know, when it comes to most applications, and you know, there's a saying about standing on the shoulders of giants, right? So we've developed all this stuff that you can now go up the stack and focus on innovation, but all that other stuff had to be built over time. So, you know, maybe 25 years ago, you know, we were just starting to see things like the LAMP stack, which is something that you're probably familiar with. But really the integration level at that point was just kind of, you know, you're scripting on top of it. It's a pretty standardized, you know, sort of, you know, stack that doesn't have a whole lot of versioning or anything like that. So you could pretty much expect that it was going to be there. But you didn't have, you know, layers and layers and layers and layers of frameworks and, you know, numeric libraries and things like TensorFlow and all the packages on top of that. And then, you know, domain specific languages on top of that and all these things that you have today. So, so in a nutshell, the environments were a lot simpler. Now, what that meant is the developer had a lot more work to do because you have to develop all this functionality, but you didn't have to worry about so many, you know, you didn't have 150 components underneath your code like you do today in some cases. And those versions all had to be managed and matched and updated when there's security updates and all that stuff. Maybe you had 2 or 3 things. You had a compiler, you had a runtime library of some sort, and you had an operating system. And it was a very basic, you know, or, you know, not necessarily basic, you would have Unix or something underneath. But the point is, you know, as these sort of development stacks got more and more complex, now the issue is, you know, I don't know if you've heard the term "it works on my machine," but it's a very popular, right? You give someone some code and they're like, well, it doesn't work. And of course, the immediate answer is, well, it's working right here. Look, and the reason it's working is because you've honed your development environment. You've installed all these packages. You've made sure that it works with the exact version of everything that you have. But now they're running it on their system. And unless they're time sharing on the same system you're on, they're not using the same versions of everything, right? So the beauty of a container is that it allows you to virtualize, and I use the term virtualize not in a hypervisor sense, but in kind of taking something and abstracting out, you know, some of the underlying details, but virtualizing both the application bits as well as their dependencies, as well as the metadata required to have someone assemble it and run it somewhere else. So if I'm giving you a simple piece of code where all you need is a, you know, C compiler or a Fortran compiler or whatever, and, you know, a very basic operating system, you can get that working pretty easily. But now I'm giving you a model that is based on, you know, a deep learning stack, for example, or, you know, some very complex, you know, chain of HPC tools like, you know, multi-threading libraries and MPI and things of that nature. So now you have to build all that stuff before you can even run my code and install it. And it's not, in some cases, not trivial to install. And if you get just even a slight mistake with the versioning, now you get different results, or you just get a complete failure. So instead, I can just give you this container, which is a virtual, in a virtual sense, it's really nothing. It's a set of instructions how to build an environment, and then you have a tool called container runtime that will actually process it. And we'll get into that in a minute. And now you can run it exactly as it runs in my environment, because by the way, my environment is that container. So I've given you a fully working environment that you can just type, you know, run or whatever the equivalent is. Plug your data in or your parameters, and now you don't have to worry about my code working. Now it's really about, can I adapt this for my own use? And by the way, you can even derive your own custom versions of it without having to go back and figure out how to rebuild everything from scratch. So incredibly valuable. And what it does, to your point about moving up the stack, it allows people to really focus on their domain of interest, right? Not so much worried about how the algorithms work underneath. Which is a good and bad thing. I mean, there was a time when, you know, if you didn't think about that stuff, and even to this day, I mean, it affects how your code scales. If you don't actually understand how things are put together underneath, you run into performance problems and scaling problems and so forth. But for the most part, the way things are today, you can focus on a very specific problem domain. Like maybe you're interested in natural language processing. Well, you can worry about those algorithms at the very top of the stack and not really care about any of the pattern matching stuff underneath, or the data management or anything, because that's already all built into frameworks. And if you start with somebody's container, you can now layer on top of that and put your own custom algorithms on it. So it's really a fantastic technology for developers. It's an even better technology for systems management people, for your IT and your DevOps folks, because now, when it comes to deploying applications, well, they don't have anything to do other than take what you've already built and make it available on a system. And there's all kinds of tools that exist for that. In the past, you had to install software, you had to tune software, you had to parameterize it. Now you take these containers, you plug them into a platform like, let's say, Kubernetes or Jarvis, which is what Nimbix develops for HPC. And now you have the ability to do large scale application deployment to where the end user can just click to run versus having to worry about, what directory is it installed in, what system do I need to log into, what is my configuration file correct? None of that stuff matters. And of course, the system administrators don't care about that stuff either, because they assume that the developer or the vendor's container just works. And it's really just a matter of plugging it into a framework of some sort. To your second question, where do these things come from? If I know I'm talking a lot, you can stop me if you want.
Feel free. No, I love this.
So really, if you kind of take a trip down memory lane, so way back, I would say way back in the 70s, there was a concept in Unix of chroot, which is a system call, which actually pivots your root directory in a given process. And now your file system starts at that directory instead of /. So that's called a jail. Now you can take an application and run it within that jail. Now the flip side of that is that you have to have all the libraries and configuration files and objects and everything within that region. You can't access stuff below that. But that created kind of the jail environment. So there was all kinds of interesting stuff people were doing with that. One of them was building code against different versions of libraries. So again, one of the things you do with containers today, but back then it was actually very innovative. And then, sometime maybe about 20 years ago, and really this kind of came up in the web hosting market. So before there was access to self-service cloud, if you wanted to host a website, you had to go and make a contract with a web hosting company and get space on a server or a dedicated server, and there were different pricing tiers and so forth. And the problem with space on a server is that obviously you had many websites running on it, and you could see each other's, while you could still secure things very nicely with Linux underneath or whatever, it wasn't completely isolated. You could still impact somebody else's website. You could have a CGI that ran, that did rogue stuff, et cetera, and affected the server. So one technology that came about was on the Linux side. And by the way, this originates, if you go back even further, we had domain technologies on mainframes and things of that nature, where you could actually carve up machines into sections and make those sections kind of static virtual machines that you would hand to somebody to use. But I'm not going to go back that far. So about 20 years ago, you had technologies like OpenVZ, which were created what's called virtual private servers. So sharing the same kernel on the Linux operating system, you now had an entire sort of virtual machine, but without the kernel and drivers, which is a bit lighter weight. But it combined things like, like network security, like process security with your own file system. But again, allowing service providers to carve up a server and not have to buy a dedicated machine for the user. So it really brought the price of web hosting way down while keeping it really secure. So for like $20 a month, you could host a website. And I'm sure now that number's down to like free or pretty close to it, because these technologies are there's different ways to make money now for these providers, right? But that still was a very sort of, somebody had to provision an environment for you that then you could then use. It was not self-service in any way, although there was tooling built around it that enabled it in some cases. But for the most part, it was very static, the carve out of an existing system. Then came Linux containers, and what Linux containers are is a combination of three things. One is that chroot jail that I talked about, or that root pivot that I talked about earlier. The second one is namespaces. So now you can actually isolate, the processes that I run in my namespace are not visible to you, even though I already have security on Linux where I can't affect them. I can't even see them. It's a completely different namespace, and the namespace also supports networking and other forms of things underneath that can keep things isolated. And the third thing is this thing called C groups, which is very fine-grained controls of limits that can be placed on not just one process, but the entire sort of process space that runs in that container. And those things go from like CPU to memory to specifically what devices can I access. So if you can imagine having a bunch of GPUs on a server, maybe you want to give access to just one GPU to your application. You can do that with C groups, and the application doesn't have to be written to figure out which GPU it is, because that's all virtualized as part of that C groups environment when the application gets it. So something was actually needed to assemble these things, and we started seeing a technology called LXC, which is kind of a lightweight shell around these three concepts. And what LXC allows you to do is launch a container effectively that's made up of some files on disk on a file system. And you can actually be root in that container and not worry about, you can delegate that level of access without worrying about that root user being able to access anything outside the container. So it opens up a lot of really interesting possibilities. And then finally, what kind of grew out of that was Docker. And I think Docker brought two innovations, and that's what most people are going to be familiar with these days, is actually Docker. Docker brought two innovation, and there's plenty of innovation with Docker, but really two innovations that are really key. One is layers. So instead of having an archive with a bunch of files in it, you have layers that are basically diffs of the previous. So now, when I store that in a what's called a Docker registry, which is basically just an object store with a directory in front of it. So Docker Hub, GCR.io, NVIDIA's container registry, these are all examples of Docker registries. Now I can basically say, well, this, and the second innovation is the manifest, which actually lists out which layers, and the layers are globally unique identifiers. So when I give you a container, let's say, it's basically a manifest that says, grab these 500 layers in this order, or 200 layers, or whatever it is. It could be 10, it could be 1, it could be, a million. And what the Docker runtime actually does before it actually launches the process in that container is it caches all of those layers if it needs to from the respective registry they came from, and then it actually assembles them in what's called an overlay. So each layer is an overlay on top of the previous one, and then finally it runs. So each time you add to that, you're adding layers on top of it. So that was a huge innovation, both in terms of how stuff is distributed as well as how it's stored. Because now, if I have 1 million applications that are based off, let's say, an Ubuntu container base image, I don't need to store 1 million copies of Ubuntu. I can have one, and then I can have these diffs, on top of them. And by the way, if I have a diff that's exactly the same as your diff, like a very simple operation, like adding a package, the container registry will basically hash that and say, oh, this is the same as that one, so we'll just share it. So it made a huge difference in terms of how things are stored and managed. And then when you actually run the container, how it's cached locally to actually execute. So the Docker runtime will not pull stuff that it already has locally. So globally speaking layers, right? So that was a big innovation. And then finally, what Docker led to was this thing called, which the OCI, the Open Container Initiative standard, is based on Docker. That's kind of what they started with, and that's actually been plugged into platforms like Kubernetes. So what you can do now is, as long as your container runtime is OCI compliant, it doesn't have to be Docker, but it can work on something like Kubernetes, and you can feed it Docker packaged containers, which is de facto standard in the industry, and not worry about how exactly they're going to be executed, because it actually adheres to a certain set of standards. So it allows innovation even in the container runtime. For example, maybe there's better ways to do, containerization on a specific architecture or for a specific use case, and that can all be done transparently by the platform. And all the developer needs to care about is, here are my bits in this format, which is the Docker format. So that's a very long-winded answer to where these things come from, but hopefully it covers, most of the bases.
Oh, totally. I mean, first of all, thank you for that answer, because I feel like that's, answered a lot of different questions that I've had personally, and of course, I'm sure everyone's having a lot of fun here. I do see quite a few questions from the live chat, and I'll get to those in just a moment. But what I really love about the answer that you gave is that as a developer, it makes me very happy that instead of just shipping my code now, I can ship the entire environment to run it on, right? That makes everyone's lives so much easier, right? Solving exactly the problem that you mentioned, right? It works on my machine. That's happened many times to me personally. And I feel like setting up environments is one of those things where we end up wasting so much time, so much human potential and time is wasted in just setting up and making sure that things work as infrastructure for your code to run. I remember back in 2016 or maybe 17 when I first gotten into more advanced deep learning, and I was setting up a whole GPU rig for myself with Linux and stuff. The main thing that I had issue with wasn't even the actual deep learning development. It was just, how do you get the NVIDIA GPU drivers and TensorFlow and everything to talk to each other, right? Yep. Because it's pretty complex, right? We've got all this different software talking to each other.
Exactly. Actually, and if you don't mind, you bring up a really, really good point. If you think about, because you're talking about specifically doing science, right? I mean, you're developing an application, but you're really focused on the science, not so much the systems management side of it or how it's going to be deployed or anything like that. So what you don't want to do is, you don't want to have the data scientist have to also be a data engineer, And the engineering part is actually figuring out how to stitch all that stuff together. Now, there's very valuable knowledge there, and that should be, somebody has to do that. But you're right. First of all, it's not natural for most data scientists to think that way. And it's also not natural for most engineers to think in the way a data scientist thinks. So those are relatively specialized skills. So why would you waste time cross-pollinating that when you can completely separate the science away from the engineering? And the engineering is done for you, or is available because somebody else figured out how to do all these things, which is kind of the basis of a base image in Docker terms. And now you can focus strictly on your unique, scientific contribution, and maybe you end up with a bit of engineering, and now you package that, and now you make it available to somebody else, and you kind of pay it forward that way. So yeah, it's unlocked a tremendous amount of innovation. And I remember seeing a job description that somebody showed me saying, hey, this is really kind of the one of the thesis that Nimbix had when it started is in terms of democratizing HPC and innovation and so forth is if everybody that has an idea for an algorithm has to learn HPC systems management, it's just too much of a barrier to get into it. Yeah. So why can I not just consume it as a service, do my algorithm, and then just focus on that? And the job description I was referring to is there was some kind of data scientist position open at a telecom company that I'm not going to name, but you're probably familiar with it. And half of the skills required were literally like installing packages on Linux, version control. And it's like, well, that has nothing to do with some of the things a data scientist would do, right? Specifically and then or specific skills with a framework like TensorFlow or anything like that. So it just seems like that person doesn't exist. So what you're doing is you're taking a very good data scientist and you're asking them to bolt on like mediocre sort of engineering skills, and vice versa, right? And that's just not good for the planet. So why not just, take the distributed way and leverage what others have done and solve, you focus on the problems that you want to solve. And you can do that now, which is something you couldn't do, years ago.
Absolutely. I mean, it's really a win-win. We're just increasing efficiency here, right? If the engineers are going to be setting up the environments anyway, they might as well ship them too, right? Why should we expect the data scientists to do that themselves? And, I remember back, this was back in 2018, actually, when, me personally, I didn't get into like data science, machine learning first, and then also end up learning about programming. I was more of like, I used to program, and then I learned about the world of machine learning. And so I had, previously, when I was younger, wrongly assumed that, hey, yeah, a lot of the people that work with machine learning, they must be pretty good with, the actual engineering and the computer science and the sort of, working with tech in that way. And when I actually got a little bit of experience in the industry, I realized, you know what? No, the tools that we have today enable data scientists to specialize in particularly working with the data and writing those algorithms and doing the science.
Right.
And I feel like that's really special, and technology like containers really enable that. It sort of makes it worth it and almost makes it possible to go on to a higher level than we ever could before. Maybe a good analogy actually would be like, different high-level languages versus low-level languages have different levels of overhead, right? But the level of overhead that you're willing to give it really depends on your specific use case. But what's really interesting is, based off of some really fundamental innovation, you can make it so that overhead is so little that you don't really care, right? So, for example, languages like Java and Go will do their garbage collection, Swift will do automatic reference counting, and now with the new Apple processors, they have hardware acceleration for automatic reference counting. And so, you can imagine that now it's much more worth it to code in something like Swift, and you have less of a reason to necessarily go to something like C and do things yourself. So similarly, these containers make it so, you have less of a need to do things manually yourself. So much of the community is helping you out with actually setting up your environments and doing these things. So there's no reason not to, use what the community is working on together, right?
Yeah.
So it really does help.
And then I was going to add to that, it's also versioned, right? So, and this is really, really important in high performance computing as applied to industries like aerospace. So for compliance reasons, let's say 10 years ago, you designed a jet engine, and, heaven forbid, 10 years later, the engine had an accident, or there was a maintenance issue or whatever. And let's keep it not so morose, right? Like, let's say it just failed before it was actually, put into use. And all of a sudden now, the regulators are like, well, let's figure out why. So it goes all the way down the chain to the designer. Now the designer has to rerun a simulation that they did 10 years ago. Well, guess what? The version of the fluid dynamics software that you used 10 years ago is like 10 revs older than the one that's available today. And it would be in the old days, what you would do, I'm not that old, but let's call them the old days. You would actually maintain these systems as single purpose, sort of machines that for 10, 20 years that you could then use, whether maybe they weren't single purpose, maybe they ran 2 or 3 versions, but they were kind of like that. So if you had to go back and rerun that simulation, I can go to that old computer and do it. But now with the container system, if those applications are actually containerized, I can run any version of that application without having to install it. And I can produce, and as long as I trust the integrity of, how that was done, which there's all kinds of ways to do that. There's tagging, et cetera, et cetera. And version control is an incredibly mature process, as you're familiar with. So now I can take that and run it on my laptop and recreate that simulation. Maybe it runs in a different amount of time. Maybe it's way faster because I ran the last one 10 years ago on a supercomputer. Well, now my laptop is faster than that supercomputer was, right? That's quite possible. Or maybe not. Maybe that supercomputer has 1,000 nodes and, whatever. It doesn't matter. The data is the same. And the results are the same. So I can go back and recheck that. And that's a compliance, regulatory compliance that these industries have to live with. And if you don't version your applications and your configurations along with your data and your environments, you cannot guarantee integrity and repeatability that way over a long term. You might be able to do it for a couple of years, but when it comes to like the service life of some of these goods that you've done, you've kind of figured out the simulation, you need to be able to go back and do it again, should something happen in the real world that doesn't reflect in your simulation, right? From a, more sort of personal developer perspective, maybe you get different results when you use one version of a framework or another. And you want to make sure that when you give me your code for me to validate or to run through my own data with, that we're talking about the same, sort of level of results, because you're guaranteeing that by versioning the exact dependencies that I'm using.
Right. I feel like I really love the example of you set up the server and all the software for, the fluid dynamic simulations or whatever, and then you come back to it 10 years later and you're like, well, we don't have that server anymore. I've seen so many instances of, I've seen data centers of really, really large retailers, for example. I actually went to the data center and there were some computers where you're like, why do you still have those? And literally their answer would be, well, they have a lot of legacy software on them, and we quite literally can't shut them down because we're not sure if they'll turn back on again. So there's all sorts of issues around that. And at the same time, I have seen so many amazing technologies that were developed back in like 2009, 2010. I've seen one at IBM that I'm not sure if I can name, but there's this one technology, for example, that at its time was absolutely revolutionary and was, I think, is just a historic example of, say, machine learning in action. But then just because back then we didn't have the similar technology, all those dependencies are gone, and the data sets, we don't know where they are anymore, and the code split up on 50 different repositories on different people's repos, and we can't really reproduce it anymore, right? So there's so much of a disservice to the community by not using this kind of technology. I feel like it definitely is really important.
Yeah, and another point you brought up there that I think is important to touch on is the mobility that you get when, and by the way, you get this with VMs as well, if you think about it. I mean, I think containers are, in some ways, they're a kind of an evolution of VMs. They're not really. A lot of containers are actually running VMs today. Most cloud providers use VMs as their backend. So when you're running Docker runtime on like AWS or IBM Cloud or whatever, you're actually using a VM underneath, right? On a Nimbix cloud, you're not. You're using bare metal, and Nimbix has some innovations, some inventions that allow that. But the point is that if you want to move your code around, because and there's the practical matter of like you mentioned the 10, 20-year-old system. The problem with that is not so much, even if you kept it running pristine the whole time and it did boot back up and all that, well, that operating system is end of life. So if there's a new sort of attack that you need to protect against, you can't patch it. The tooling to manage that operating system doesn't. The rest of your systems don't know how to talk to it. So now you have to manage that with its own tooling or heaven forbid on the console, right? Which we don't want. So, I mean, imagine trying to do that at scale, right? It just doesn't work. So the point is, well, how do I move my code off of that? Well, I need to be able to reproduce that system somewhere else. Well, again, with the container, you get that. And in a multi-cloud context, and this is actually something that the major cloud providers don't find so flattering, because at the end of the day, they all provide the same class of service, right? When you look at infrastructure service, whether it's on Amazon, Google, Microsoft, or IBM, and they're all going to tell you they have additional values, and of course they all do. But fundamentally, what they do is they provide compute, storage, and networking, and that's what any cloud provider and some form of security and authentication around that. But the major services are compute, storage, and networking. So given that they all provide that, as a business customer or even a personal user, why can't I just go to any of them and run my code? Yeah. Well, the answer is because if you coded it to their API, then you're stuck. You have to now migrate it, right? Well, with a container, I simply go and just instantiate it somewhere else, and that's it. I'm done. And now, of course, Azure is going to have better, performance on X. Amazon's going to have better scale on Y. IBM maybe has some other value, but the code still runs. And as long as you're not, incredibly sensitive to things like timings and gigabit versus 10 gigabit or whatever, which most code is not, right? It just affects the performance, but it doesn't actually affect the results. Then now you can run that anywhere. And what it means for a business customer is they can actually shop now by price or availability or scale or compliance. If they're in a certain region where, this cloud doesn't have a data center there, then they can't use it. So they have to use somebody else's. If you're an individual user, you go where the best deal is, or where, if you wanted to try something out on this new GPU and that GPU is only available on Azure, you go there, right, or Google. You don't have to worry about migrating. You just simply go and, launch an instance or if they have an actual container interface, point at your container and just run it, right? I mean, that's tremendous. So what a container gives you is the performance of effectively infrastructure, because you're not adding overhead. As you mentioned about the overhead, the container itself doesn't actually add any overhead at all. It's using Linux primitives that are just built into the kernel. You're not creating like another virtual machine to run stuff. You're simply defining some security around some processes and then presenting that to the end user. There's no performance overhead naturally. The container happens, but you get the agility of VMs by being able to move things around. But you don't need to store VM images, which are gigantic, because you have to include the operating system, the drivers, all the libraries, all that stuff. All you're doing is you're including your application, the dependent libraries, and again, if it's in a registry and somebody else has 80% of your stack the same way, it's not going to be a copy of that 80%. It's going to be a reference to that 80%. Mm-hmm. So it allows us to really distribute these things a lot more efficiently. So it just really increased mobility of code. It just shot it through the roof, and it eliminates the problem. Now, it doesn't fix the problem of today having to deal with a 20-year-old system, but moving forward, and I would say probably, you think of Docker becoming kind of enterprise stable probably about 5-6 years ago, and people actually started using that, technology then, it's been around a couple of years before that, but now, you can say that anything built in the last 2-3 years won't suffer that fate.
Mm-hmm. I feel like you're right. Portability and mobility really are key because, first of all, it kind of forces a lot of these cloud providers, for example, to add a lot more value where previously It was just once you're locked in, right? Like a perfect example is, once if you code it against like an AWS API or you're just using VMs on AWS even, switching over to Google or IBM or whatever, that's a pain, right? You've got to manually do all of that, reset things up on other providers. But now with the power of containers, it's quite literally just, I don't like your services. Mostly, code is portable and isn't sensitive to the very specific machine it's running on, so you can just ship it over to something else pretty quickly. So I feel like that is a really interesting way to look at it. And I think really important from both a developer and a business perspective. But you also mentioned that, there are different ways that these containers are deployed, right? So, like, for example, on IBM or AWS or whatever, you're still running a VM and you're running it through that. But then on Nimbix, for example, you're running it on the bare metal, which enables that amazing performance which is really necessary for HPC. So another question that I have is, well, what exactly are those innovations that you mentioned? So how are we actually using containers in high performance computing, and what what are some of those special challenges that high performance computing has that you got to solve in order to apply containers to this sort of field, or even what makes containers special and actually more applicable in the field?
Yeah, that's a great question. So since you mentioned innovation, I'm going to do a shameless plug for Nimbix inventions because I think.
Definitely.
So first, and this is actually predates containers, but Nimbix invented reconfigurable cloud computing, which you can think of as one of two things: either serverless computing or infrastructure as code, as we think of it today, where instead of saying the traditional approach on cloud providers has always been, or has been until they started layering higher level services on, has been go launch your instances, set up the virtual networking between them, set up the storage, and then maybe you start with an image that has some tools in it, but really you have to go and install a bunch of software on this stuff and then run your application, right? But the problem you're solving as a user, especially in HPC, is you're saying I need to run this simulation. So this is kind of how the problem starts. I need to run this simulation on 100 nodes, say 1600 cores, and I need to use this data set. And here are the parameters I need to pass into the solver because I wanted to do I want to do a frequency sweep on an antenna or whatever, and I've got to tell it which position the antenna is in, whatever. I say whatever, but these are the kinds of problems that our customers are solving. They're pretty. They sound mundane, but it's like if you saw what goes into like simulating whether like a mobile phone will be able to transmit when it's held in different positions. Well, guess what? They don't build it and then hope it works. They actually do what are called parameter sweeps on electromagnetic simulation software with the model that shows if I turn it sideways, it's still transmitting. You might remember the antenna gate controversy, right? That stuff doesn't really happen anymore because now it's all simulated and it's done specifically to solve that problem. But the problem space starts with this solver, these parameters, this data at this scale, right? So why can I not talk to the cloud that way? Well, until Nimbix invented that, you couldn't, right? So we call that reconfigurable cloud computing. So, and it does two things. It allows you to specify that to the actual cloud endpoint, and the cloud goes and provisions all this hardware for you automatically, and then runs your solver and then gives you back the results. It's also, pioneered something called a processing API, which instead of using a machine API to actually talk to the cloud, you were defining in a very simple. If you look at the API calls that are used to instantiate a very complex workflow, and I think you've seen them if you actually used our portal, it's like 20, 30 lines of JSON, right? And it looks like English, right? It says this application, this value equals that, the value is a parameter that you would pass into it that you're familiar with.
Yeah.
My data set, and then, like this machine class times these number of nodes. Mm-hmm. And that's really, really straightforward for anyone to understand. You're not setting up like, this group of instances with this VPC, this class of storage, all this different stuff, before you can even get on there to get your code loaded on there. And then you have a whole different set of problems as you described earlier. The second innovation that enabled was that now you could actually, because it was reconfigurable instead of shared, you didn't have to actually slice machines up with VMs to prevent tenants from stepping on each other, because each tenant, when they ran a workflow, was actually consuming the entire machine or group of machines for that period of time. And when their workflow ended, it was basically torn down, flushed, and then the next workflow came along before it. So it enables batch processing in the cloud, which is different than, if you think of the two types of applications that exist in the cloud, just a very broad stroke, you have service-oriented applications and you have job-oriented applications. So when you've got something, you have a client that's actually sending data back and forth, could be a web browser, could be something you take a picture with and then it tells you, it categorizes for you. Well, it's uploading the data to a web server somewhere. There's some processing that happens and then it's sending you the result back. That's a service-oriented application. It's waiting for requests to answer with a response. A job application is like what you would do in science and engineering when you're trying to solve a huge problem. It's like in deep learning, right? I've got a petabyte of pictures. I want you to categorize them. Mm-hmm. Well, that's literally like a description of one job, right? Even though it's gigantic. At the end of that, you get a model. And then you can either run it again or you can do what you want with that model, right? But that's the convolutional neural network, training, right? So that is an example of finite, like you say, hey, I want to do this, give me the results. And that's a very finite thing. When it's done, I don't need those machines anymore until the next time that I need them. versus when it's a service application, I need those running 24/7 waiting for requests because I never know when someone's going to take a picture and want to categorize, right? Mm-hmm. Very different thing. So Nimbix reconfigurable cloud computing enabled batch processing at scale in the cloud on bare metal, as well as, the other part of the invention is programming your accelerators like your FPGAs and your GPUs and whatever else you might have plugged into that cluster to support your application before shutting everything down and handing it back to the next tenant, right? So that was kind of our big invention there. And then the second thing that happened when we saw in 2012, 2013, yeah, that's great, but how do I get my own code? How do I do self-service on that, right? Mm-hmm. Well, obviously, I'm not going to give you a VM because I just invented something that makes VMs obsolete in the cloud, right? At least for that use case. So containers became a very obvious thing that Nimbix started looking at. Now, at the time, because I remember we were talking about this stuff in conferences, and actually, even before I joined Nimbix, Steve was talking about this stuff, and the HPC purists were like, "Oh, that'll never work. That's crazy." They couldn't wrap their head around VMs, much less containers. It was just something insane for them because why would I need this? I can just install the app and run it. Well, they didn't hear the self-service part. They didn't hear the mobility part. They didn't hear any of that, right? And then cloud was like a whole other thing. Like, there's no way we'll ever do HPC in the cloud. Well, guess what? We're doing HPC in the cloud, period, right? We just are, and we're doing it at scale, and it's not replacing on-prem HPC, it's extending it. Mm-hmm. And that's just happening now. But 7 years ago when we started this process of inventions on the containerized side, it didn't really exist. So we kind of saw that, and we said, okay, we're going to invent the system that allows developers to have self-service to onboard apps without having to resort to machine images and things of that nature that are kind of standard on other clouds. So that's actually dynamic containers and cloud computing. It's our second sort of group of inventions. And then you saw, like 2 years later, you started seeing containers kind of emerge in HPC in the research space. So it's things like Singularity and Shifter from NERSC and so forth. So people started catching on, but we'd already been going to market commercially with this for like 2 years. We had customers, and the customers that were running this that weren't developers, they couldn't even spell container. They didn't care. They were running their solver exactly as we said. The difference is that instead of Nimbix Cloud having at the time having call it 5 or 6 solvers, it had like 100. And why? Because now we could onboard them with the and not just us onboarding them, we could actually have developers onboard their own code without having to actually understand the complexities of the infrastructure underneath. And that's what that innovation kind of unlocked. As far as what are some of the challenges for containers and HPC, I think the performance one is obviously a huge element, and which is why, like in the Nimbix cloud, you have InfiniBand as the fabric. And the InfiniBand is available to you as using your MPI in a container to be able to do, distributed applications with very low latency. And today that's also true on Azure. It wasn't true at the time, but this is something that Nimbix has been in InfiniBand standard since day one. Another challenge is, if you look especially in the commercial application space, like when it comes to solvers, from commercial companies for fluid dynamics and things of that nature. They're very, very, very large. It's not just data, the code itself. It's the typical pattern for like a good Docker container or a typical Docker container is probably like, a few dozen or even 100 megabytes, and that's it. Where some of these applications, when you install them, they produce 40 gigabytes of files on it. So there's some tooling issues with doing that. Now, thankfully at Nimbix, we figured out how to solve for that early on, both in terms of the building side, as well as the actual deployment side as part of our service. And then some other innovations kind of came through in Docker later, things like multi-stage builds, which actually make that a bit more, palatable than it was before. But those are some of the big challenges. I would say the size and of course, getting the performance right, so you're not locking yourself into not being able to use high performance fabrics and so forth. But the good news, Tanmay, is that we figured all that stuff out. So all you have to do is kind of look at our patterns. And of course, if you run them on other clouds, you're not going to get the performance that you get on the Nimbix cloud. But the good news is that because our Jarvis cloud operating system is now available on other clouds too, you do get the exact same user experience. Mm-hmm. So it doesn't matter if I'm a customer and I have, and I want to use 4 public clouds plus my own on-premises thing, I can still use Jarvis to be the app store / workflow automation for that, and the entire catalog of applications that come with it. But now I can direct that to just about any cloud that exists out there.
Wow. I mean, I gotta say, I feel like technology is really, really innovative and really, really meaningful when the technology gets abstracted to a level where you don't really think about the fact that you're using that technology in the first place, right? Like when you unlock your phone with Face ID, you're not sitting there thinking, my phone has a neural engine powering a convolutional neural network that's looking at my face and identifying, right? And similarly, when you open up Nimbix Jarvis, you're not sitting there thinking, I'm going to be using a Docker container with this specific application on it. It's making my life so much easier. It just works, right, for the person trying to do the science. And that is what I think it makes that technology so meaningful in the first place. And that's what makes the experience so powerful. As a matter of fact, something that I do want to do now is actually answer a couple of questions from the live stream. So we're getting a question from Shiva. We may have covered this a little bit before, but Shiva's asking, could you please tell us something about the life cycle of a Docker container?
So without context, it's pretty broad. So I'll kind of hit it from a few different angles. But the life cycle, that's actually a really interesting. There's a really interesting point that I kind of left out earlier. Containers are ephemeral in the sense that anything that you do inside the container, as long as it's not actually pointed to persistent storage, so you can take your container, you can attach volumes to it, which is where you would put your persistent data. But if you write to like temp directories or even to like your home directory in the container or whatever, typically that gets thrown away when you exit, when the container actually finishes. Excuse me. That's a good thing, because that means that the next time I run it, whatever garbage I didn't get committed to the actual base container image and now pollutes that's the whole point of like the pristine environment every time you launch it. So the life cycle of a container at a high level is from the minute it starts, the minute it ends. And then, in terms of the changes that are made to it, there are no changes that persist other than what you explicitly direct to a persistent volume. So I'm not really sure, what else to say about lifecycle in that context. I'll say that like if you put it in the software development lifecycle, like if you were plugging container builds into like CI/CD pipelines and so forth, it's actually very similar to like building a container. So if I were to kind of step back a little bit, a very basic way to think of a container, especially a Docker container, is an installation script that has all the artifacts you need to install built into it. And then, so that's kind of what gets packaged. And then when you run it, you're just executing what you install. But you're doing that all within that contained environment, right? So from a software development lifecycle perspective, you can actually version control the Docker file itself, which has all the instructions on how to use your installation script effectively. You can version control your source code, or even some binary artifacts if you want, like pictures or whatever it is you want to put in there, documents. And then you can actually just run Docker build, which would be the equivalent of running make on a source tree. And that can be plugged into a CI/CD pipeline like Jenkins or BuildX or Bake, from Docker, et cetera. So there's all kinds of ways to do that. So that would address kind of the software development lifecycle, and it's versioned just like code. So it's like I want to build version 9 of this container. Well, I can check that out from Git and just build it. And as long as I'm doing normal, disciplined, version control that I hope all developers do, although I know for a fact not all do. Then we're good. But I think the lifecycle question was probably more about, the ephemeral nature of container runtime.
Very nice. All right. So, I mean, again, that was a little bit open-ended, but I mean, that definitely covered most of the points that I'm sure Shiva would want to ask. Again, any follow-up questions, feel free to put them in the live stream chat. Now, something a little bit further removed from containers. Just a quick mention, maybe. This is a question from a quick page on YouTube asking, why do most young developers, or I would just say developers in general, use Mac, and I'll also say or Linux? Is there a reason? I mean, I definitely have, a couple thoughts about that, but really quickly, do you want to maybe share a couple thoughts as to what your preferred development platform is and why?
Well, I'm definitely so I'm kind of unique in that way. I'm not an Apple fan, let's put it that way. I respect them, but it's just not a platform that I enjoy using. But Linux for sure. I mean, Now I use Linux on Windows,
Mm-hmm.
actually use Windows. WSL is a great development environment, et cetera. But again, if you're using Docker, it really doesn't matter. You can run Docker for Mac, Docker for Windows, Docker for Linux. It's all the same. Your container is all the same. It's still a Linux environment in your container. Why do developers use Linux? If you have to ask, no, I'm kidding. It is just, it's such a friendly environment for the fact that you can quickly script things to figure out if things work or not. The fact that there's so that's and then I don't know. I started using I was using Unix before Linux. Linux didn't exist when I started, so I was using Unix, and I thought Unix was the coolest operating system on earth. I still do. Kind of the Unix family of operating systems, including Linux. But also just if you look at the body of examples of a lot of people, and I don't encourage copy and paste from something like Stack Overflow, but we all Google stuff and we end up in Stack Overflow pretty much on a regular basis. It's just the way it works. There's a whole lot of information on there, both that we're contributing as well as others are contributing. And that is almost exclusively, or at least a large majority, unless you're Googling specifically for some Apple framework or some Microsoft framework, you're gonna end up with code that runs on Linux or concepts that run on Linux. I don't know what else to say about that, but as far as the Mac thing, I think I think Apple makes great hardware, but I think it's also kind of telling that if you look at the sort of interfaces that most developers are using on Mac, they're kind of the POSIX type interfaces. So you're opening a terminal and doing stuff, or you're using Docker, you're using it to SSH into a server that's running Linux. So it's not necessarily, unless you're building applications for that platform, it's not really like a preferred development environment, if I should.
Yeah.
The good news is that it's really a matter of personal preference. And one thing that cloud has enabled, I think over the last many years, is the client doesn't really matter that much in terms of, it's important in the sense that it has to be able to receive the cloud as well as cache, important parts of it. But as long as it can do that, and that's primarily a web browser and more technically an SSH client, if you wanted to SSH into a remote server or whatever, then you can run whatever environment you want on top of that, right? And in fact, if you wanted to build your code and use a specific, IDE that only runs on Mac OS or whatever, you can do that. But that code is probably going to end up running on Linux, again, unless it's an application specifically for a Mac or for an iPhone, right?
Mm-hmm. Yeah, that makes a lot of sense, right? Everybody's going to have different preferences here. I would say generally, maybe the reason that a lot of developers happen to enjoy Mac, as you mentioned, for example, Leo, is the fact that they are much closer to that Unix. They are in the Unix family of operating systems versus
Right.
something like Windows, right? Where on Windows you would be probably running WSL. Developer that doesn't want to necessarily use Linux or wants to just simply develop applications for the Mac platform would be using Mac for that sort of combination of, it's pretty easy to use, but it's also still has the POSIX compliant libraries and everything. So
right, I think it's worth mentioning, and I'm sure if anyone's watching from Nimbix, they're probably laughing because I'm like the anti-Mac guy on Nimbix. But I'm just being completely sort of objective here. I think if you look at what Microsoft has done in like the last 2 or 3 years, actually ever since Satya Nadella became CEO, has been, both in terms of contributions to open source as well as even the Windows platform itself, how easy and powerful something like WSL actually is, and how close to, you're effectively using, while the base operating system is not based on Linux, your development environment is like, it's not POSIX-like, it's actually Ubuntu, it's actually Linux.
Yeah.
There's no difference between that and what you would run, if you installed Ubuntu by itself. So I would argue you basically have the best of both worlds. You have a state-of-the-art user interface with very high performance graphics, all these different things. And again, matter of preference, maybe you don't like Windows 10, you prefer Mac OS, that's all good. But compared to like a Linux desktop, it's, having been used Linux for 25 years, I can tell you it's much better from a desktop perspective in just about every way. But you get the full Linux environment with no, /home is /home, it's not /users. There's all kinds, it lists like a million things that are just basically 100% authentic in that sense.
Yeah.
And then on the Azure side, I think Microsoft has really gone, just what they've done to enable Linux in the cloud has been very innovative as well. And that's, I would just really point to, kind of the Satya Nadella era of, kind of ushering that in, because I mean, in the 90s, it was like, Apple was in the 90s it was for graphics people. It wasn't really a developer platform, right? So that was kind of out of the picture. So you basically had Windows and you had Linux and then obviously you had your enterprise Linux like Sun and HP and so forth. But developers didn't want Windows at all, right? And they thought it was, and really Microsoft was like anti-Linux from day one up until, probably about 5 years ago, right? And yet now the tooling and enablement that they've done on Linux is pretty phenomenal, as well as open source in general, I should add. So I would say that, not to dissuade anyone. So I think everyone should use, I'll give you an anecdote from when I was like my second development job. I was very young. And I remember being like, in the office when there was people were trolling each other over what's better, VI or Emacs. And that's like literally is Mac or Windows better, right? It's like one of the dumbest things. It doesn't matter, right? If you're a fan of this, you're going to use this. If you're a fan of that, or whatever. But there was this very old, old. I mean, I look back, he's probably my age now, but he seemed old to me because I was 20. And he took me aside and he said, Leo, he's like, you know what the best editor in the world is? I'm like, what? I thought he was going to say like Visual Studio or something, right? Or whatever visual. He's like, and he says, the one you know how to use. Yeah. And that's the best advice that I can give anyone who says this is better than your this. It's like, if you're selling it to me, that's great. If you're just, arguing with me about which one is better, it's like, if I'm more productive on this platform, then it doesn't matter. Like, that's the platform I'm going to use, and I'd say that's probably true of like, when it comes to preference things. Thankfully, the cloud and just the way we work today with just about everything. And this is kind of even pre-cloud, right? When you think of server-based computing and the innovations that have been happening for the last 25, 30 years to move things off of physical machines onto remote servers and services. Think about your email, right? I mean, you used to have to run an email server and you had to actually cache your email locally to actually consume it. Well, none of those things are true anymore. Now, companies choose different types of services for security reasons. Not everyone likes Gmail or Google Apps, but Microsoft has, email in the cloud as well, right? You have all kinds of options for that. And again, these things are available to us now. So it makes the client almost, if you think about it, you're running Chrome on your Mac, you're running Chrome on Windows, you're running Chrome on your phone. It's the same client, right? Yeah. Whether you have a 1-button mouse or 3-button mouse doesn't really matter, right? It's just, that's a personal preference thing. And, I would kind of leave it at that. But I would point out that most developers are developing code for Linux, even if they're using one of these platforms.
Yeah, agreed. I gotta totally agree with that. The cloud has enabled this sort of level of portability to the point where, as you mentioned, the clients, in a lot of cases, really don't matter unless you're developing the applications for the clients in specific. In which case, yeah, that.
Well, and I would say a native one, right? Because if you're developing a non-native app, it's
exactly
it's 5. You're running it in a web browser. Yeah. Again, that doesn't matter. And think about how many apps on your desktop are non-native today, are still apps, right?
Yeah. It's going to be interesting to see for sure. But there are actually a couple more questions, so I do want to take those up really quickly. One that's pretty quick is from Rod. She's asking, do you support spot or preemptible instances on public clouds?
For the Jarvis software that actually powers HPC, yeah, I think that's what the question is.
I believe so.
The answer is yes. Now, what I would say about preemptible instances or spot in the AWS kind of nomenclature is that unlike when you're running high performance computing, and especially a tightly coupled, I think this is something really key about sort of perfectly parallel versus tightly coupled versus stateless, right? So if you think about different types of applications, perfectly parallel means that, think of a Monte Carlo simulation. Mm-hmm. Or even to some extent, neural network training doesn't have to use not the Horowitz type, but the kind that just kind of takes a batch and processes it, right? You aggregate the results later. You don't actually communicate in real time between workers to figure out what to do next. So that's one class of workload. So if a worker fails, maybe what ends up happening is it gets restarted and then it does the same batch it was doing. And then eventually the data gets aggregated. So you can have a spot instance reclaimed from underneath your code and, without a huge amount of consequence other than an inconvenience or performance degradation or whatever. But again, you're saving like 90% or whatever it is that you save when you use these things. in a stateless world, it doesn't matter, like a web server, right? Because I can scale that horizontally all day long, and I can delete and add instances. And what the load balancer in front of it's going to do, it's going to send traffic to whatever's live, right? So that's a great use case for this type of thing. For tightly coupled, something that you initiate with MPI, in simulation, it would be just about any type of solver. In deep learning, it would be distributed deep learning. If you have a rank fail, it blows up the whole process. The whole process basically fails because it's part of a tightly coupled mesh of calculations that are happening all at once. So you do not ever want infrastructure removed from underneath that type of work. So the question is, does the Jarvis technology support preemptible instances? The answer is yes, but they could actually, you should be very careful about selecting them. So Jarvis actually allows you to point, using resource requests, point work at different types of instances from the cloud and so forth. You should be very careful what you point certain classes of work at. If what you don't want to do is be running an expensive simulation that's been running for 2 weeks, and then all of a sudden one thing goes away and therefore blows the whole thing up, right? So now I would argue you probably don't want workloads that run for 2 weeks in the cloud, because cloud is every term of service for any cloud provider is going to be best effort, because that's just what cloud is. I would say that, like, if you look at Nimbix, it is 5 nines reliability, and most providers are actually up there as well. So we do make a very good best effort. But at the end of the day, these are not fault tolerant, sort of tandem type systems that will never fail, right? It's not what you put on a nuclear submarine or something. These are cheap computers, like, racked up and providing service, right? They do fail sometimes. So you probably want to keep your workloads to, scale out to run them faster versus have one server that runs for 2 weeks, maybe run it on 10 servers that run for 24 hours. That's probably your best bet when it comes to these workflows. So you're much less exposed to failure over time. Mm-hmm. Now, it's the same exposure because you've just increased your scale by 10x, but I think you get what I'm saying. Yeah. So yeah, I would say yes to Spot, but select your resources carefully when you actually go to run work.
Yeah, that makes total sense, right? It depends on the use case, which
exactly.
It's kind of.
That's why we have these options. I mean, it's really, and really one of the main things about systems resource management today, just in general, is choosing the best tool for the job at the best price, and that's really all it comes down to.
Absolutely.
So, but we just have all these options now. We can actually do this.
Mm-hmm. Yeah, I mean. Remember, it's all about the use case at the end of the day, right? It's kind of funny almost to envision a team working on like a really expensive, multi-$1,000 simulation for a week on the cloud, and suddenly, because they have a Spot instance and they were trying to save some money, it kind of just stops towards the end. It kind of reminds me of Python code that I'll run, and towards the end, but just before I save my model, after, like, I don't know, a day of training, there'll be some sort of bug. Oh, I forgot to open the file with write mode, and it'll be like, nope, can't save. So yeah, that's
you should test it with a smaller data set.
Yes,
first.
Exactly.
That's what I would say to that. Yeah.
Yep, I learned my lesson after one time a couple years ago. So, yep.
Yeah, the one thing I'll say about that, about the cost side of it, so Spot instances are not the only way to save money in the cloud. Like, if you use the Nimbix cloud, because of the low latency fabric, the InfiniBand and the bare metal, if you look at the total cost of a simulation on much fewer resources, it's usually way cheaper than it is on equivalent, sort of gear on AWS or Azure or whatever. So it's really about, when you think about cost in the cloud, you want to think about solution cost, not unit cost. Mm-hmm. Because it's almost, and I use this simple example, right? If I ask you, and you're in Canada, so the number will probably be pretty high, but what does it cost you to cool your house in the wintertime, or to warm your house in the wintertime? I don't really care what you pay for BTU or for kilowatt, whatever type of heating you have. That's just a rate. I want the numbers. Does it cost you 100 Canadian? Does it cost you 500? What's the number? And that is the actual cost per answer that Nimbix is really all about. So there's ways to save money in the cloud. You can optimize your cost per answer, or you can optimize your unit cost, which is where you start playing with Spot instances and so forth. So I would encourage people to think about cost savings as, look at it from an efficiency perspective, not just a brute force. How do I get this same thing for less? Mm-hmm. Which is effectively what these providers are doing with Spot. And
I completely agree, right? I mean, it even goes down to like the simple example of like, do I want an NVIDIA? I mean, again, this is a pretty far
Correct.
removed example, but do I want like an NVIDIA V100 or an A100? Sure,
Right.
the A100 is much more expensive, but if you're going to be running it for an eighth of the time because your use case is very specific optimizations on that card, then
Yep.
it's worth it, right? It's the total
Yep.
price that matters at the end of the day.
Exactly.
Yeah,
Yeah.
so that makes sense. All right, another question from Shiva. This one's actually pretty interesting. What do you love the most about Nimbix? And I mean, you've been working there for a long time. So could you maybe share a couple of your work experiences that you found fun?
Yeah. I mean, I love the people. I mean, to be honest, and the team, and kind of the team vision and direction. And you've talked to Steve. I mean, it's Steve's a visionary, and he's led by example the whole time. He's the guy. He's I think of Steve as the general who leads the army on horseback, from the front instead of the guy sitting in the back barking out orders, right? Which nobody ever wants to work for a leader like that. That's not really leadership. So Steve's always been the guy who's, he'll never ask anyone to do something he wouldn't do himself, or at least try to figure out how to do himself. That culture just permeates to this attitude where, a couple of things like you never hear at Nimbix, not that I'm blaming other companies, but I think specifically at Nimbix is you never hear like, well, that's not my job, or that's not my problem. Like that's something that's really not part of the Nimbix culture. It's, you may not know how to do something, but if you're involved in solving a problem, you, first of all, you can call me, you can call Steve, you can call any of the other executive team. You can call anyone on the team, and by call I mean usually on Slack. It's not necessarily picking up the phone, right? And you're gonna be able to coordinate a solution that way, right? There's no this sort of mentality where like, oh, I've got this like set of responsibilities, and if it falls outside of that, I'm just going to deflect it. It doesn't work that way. It's like, maybe I'll ask for help, but I still want to own the problem because I actually encountered it, whether it came from a customer or from a fellow team member or whatever. So I think that culture and the people that obviously uh, carry out that culture, it's a problem solving culture of customer success. So from day one, we've always been about, we don't ever want to throw a solution over the wall to a customer and say, here, go figure this out. It's like the customer says, I have this problem to solve and I want to use. So we work with the customer to help them pick sort of the best experience that they can have, the best type of infrastructure, the best, type of class of data, whatever it might be. And then we take a keen interest in making sure that their workflows actually produce the result they want to get, which is, it's a different class of service than what you get on like, let's say an AWS or another giant cloud provider, where they their support job is to make sure that the infrastructure is available. And that, fundamentally, that's what Nimbix is as well. But once it's available, like they can close the ticket, right? They're done. And whether now from there, if you can't get it to work, well, sorry, we don't offer any kind of service like that. So we offer a very concierge type service for our users. And it's something that's really just a privilege to be part of, because by extension, I personally, I know everybody on the team has, but I personally learned a tremendous amount of stuff about use cases and just domains and all kinds of stuff that before coming to Nimbix, I mean, I was like clustering and large scale computing and all that has always been my bread and butter, but just what are people actually doing with this stuff? And I'll point to like your Heart ID, right? I mean, we have a case studies page on our website that's got, I think it's got like 15 case studies where it's everything from like biometric ID using deep learning, as you've written about, to aerospace, to racing. I mean, we have race teams that are using our technology to make their cars faster, space, et cetera, et cetera. All these things that are just super interesting, and we don't have to wait for the customer to talk about it publicly. We know about it because we're talking to the customer every day, and we're understanding. And the customer loves to tell us what they're doing with this platform. So that's just really, really satisfying. Second to that, I would say, and maybe not a distant second, but for sure the technology. I mean, Nimbix, so even though we went to market as a service provider, we've been a software company basically from day one, in the sense that, we're not just here to rent you servers. We're going to build software that makes your experience, consuming these technologies a lot easier. click to run versus, provision a bunch of stuff and then try to get it working, all these different things. And that's led to a lot of innovation. And I'm very privileged to be able to lead the software team that actually does.
I mean,
So hopefully that answers the question.
Yeah, no, I'm sure it does. I mean, it's so fun to hear about how wonderful it must be to work on a team like that, right? Being able to learn so much outside of your sort of like usual just zone of what you do. And I feel like that even just helps you develop even better technology, right? Seeing where it's being used, being able to say, all right, we can make better experiences, better technology, better infrastructure, better software on the Jarvis end or the Nimbix end of things, because we know our customers are implementing these, or trying to solve these kinds of problems, we can get more specific. So I feel like that's definitely really interesting.
That's really fundamental to software, software products, especially projects. So if I think of project versus product, project typically starts out as something that scratches an itch that you have, right? Like you're really interested in this and you can't find a good solution for it. Or maybe you just want to learn how to, code in a certain language, so you kind of create a project to do it or whatever it is, but it's a personal interest driver. Whereas products, they start out that way. We have a vision for the technology, and then it's kind of a different conversation that I hope you'll have me back for, by the way. But when you talk about agile methodologies and all these different things that are being used now by product teams to actually make software better, the customer is part of that feedback loop, like throughout the entire process. So, and what I would argue is that a really good measure of success for a software product is, can the developers emphasize with the end users? So if you can feel the end user's pain, will you spend the extra 5 minutes to turn that script into a button, right, or whatever? I mean, it could be something that simple, but I would say it's really more about how convoluted you make your processes, how integrated they are. You talked about vertical integration earlier, how things work better when they plug in together easier. All these things are as a result of the user saying, yeah, that's great, but it took me 20 minutes to do something before I can even start doing my work. Why can I not just click that and have it? That's the kind of pain that you need to feel as a developer, and you have to feel it, right? It's not an academic thing. You can't just read about it. And a great way to feel it, I mean, I don't condone this for anyone, but is to be yelled at by a customer, right? Or to like have the customer tell you, hey, if I don't get this done by like tomorrow, I'm fired, right? Or whatever. That's an extreme example, but that really, and now you start, because you respect that person and it's actually a person. It's not a survey or a focus group or whatever. It's a person with a name that is saying, I'm in the deep end here. I really need your help and I need this to work. And that's what makes software products better. So I encourage any team to really get really close to their customer. And like I said, if I'm kind of doing a shameless plug for myself, but if you have me on subsequently, we can talk about agile methodology, because I think it's really a really important aspect of how the software industry's changed and what to expect today as a developer.
I mean, I gotta say, based off of how this discussion's going, I definitely do want you back on. So we're gonna have to arrange that.
Right.
But I mean, first of all, I first completely agree. We have an entire episode with James Archieri, another one of my mentors, around the world of empathy and how important it is for developers and people who build technology to realize that they're building tech for humans, right? And that at the end of the day, you're trying to solve human problems, and so it's important to be able to empathize with those people. So that definitely is really important. But there is another question that I quickly do want to ask. There are actually two questions from Hrishika that I want to ask really quickly. One of them, which I haven't heard this acronym before. Maybe you can jog my memory here. What is the future with smart NICs?
Smart NICs?
Yes.
So that refers to, and this is not my area of expertise, so I can just talk about it at a very high level, but that refers to basically network interface devices, network NICs, right? So instead of having the operating system in software do things like network security and even packet IP stacks and things of that nature, you put that in hardware. And one of the ways that's happening is with FPGAs, right? Where you're actually programming, and the reason you want it to be programmable is because every time you update it, you don't want to go off and manufacture a whole bunch of new cards. So you want to be able to make it programmable. But you program gates so that when a packet comes in from the network, instead of having to be copied and decoded at the hardware level and copied onto the host and then the host runs some software to figure it out. A lot of that can be filtered at the edge, right at the card. So it really speeds up, it offloads the CPUs and it speeds up processing, et cetera. What's the future with that? I mean, I'll give you a kind of a cop-out answer just because, again, it's not my area of expertise. There's probably people at Nimbix who can talk about it better than me, but I think the future is we'll probably see a lot more of those deployments in data center applications, particularly around things like security and intrusion detection and things of that nature, where if you think about like so the cop-out answer is we'll see a lot more of it, but I'll give you like one specific thing that I think is relevant. If you think about how sophisticated cyber attacks are and are getting, it's almost like no matter how much security you throw at something, they figure out how to break it, right? Because this is kind of the nature of the game. And the stakes really cannot be higher. We're not talking just now about rogue hackers. We're talking about governments that are actually sponsoring cyber warfare against other governments, right? And indirectly their people, right? To do a various amount of damage. And thank goodness we haven't seen like, really, really bad stuff like power grids being shut down or, permanently or anything like that. But that's not that far off into the future, kind of the drive to do that. So the faster we can make detection of that kind of thing, and the faster we can, and the more agile we can make it, the better. So by offloading a CPU and not having to write a bunch of software that runs at CPU speed, and putting it right at the edge, we can maybe detect a lot of that, inbound attack. And by more agile, by making that programmable, when they figure out how to get around it, we can quickly spin a new version of it and patch it without having to worry about manufacturing new cards and doing stuff. So I think it's really about speed and agility, and of course, eventually that drives down cost. So I can definitely see data centers, service providers really using that technology a whole lot more.
Yeah, I mean, definitely not my my area of expertise, but it's definitely nice to get your opinion on it, Leo. And again, any more questions follow up, feel free to put them in the live stream as well. But one more question from Rishika, and they're asking, any guidance on project-based learning for beginners on learning these concepts, things like Kubernetes and Docker and containers, since there's a mismatch between what they're teaching in universities and what the industry actually needs?
That is that's a whole episode right there by itself. But without getting into the whole concept of skills-based learning versus academic-based learning, because I think they're both important. I think there's concepts that are important to learn academically, whether you do that independently or through university. But there's also some very specific skills that are important. And this is really, as someone who's been in the industry for 25 years, I can tell you your skills are your hard skills are way more important when you're trying to enter than they are 25 years later, where your soft skills are what really take a whole new meaning, in the sense that it's important that you know how to do things and you understand things at a fundamental level, but being able to deal with people and being able to convince and persuade people and lead people and so forth are also equally as important. But getting back to skills in general, like hard skills, how do I learn these things? So I would encourage, so first of all, the good news is it's all free in terms of the tutorial material. Now, is that as good as something that a university or a MOOC would offer? Maybe not. Maybe it's a bit more, you have to be a bit more self-motivated to really consume that. But I can tell you that, when it comes to containers themselves, I'll say don't fear containers. They're actually way simpler than you think. And I would say that the first thing you want to do is you want to think about them in their most fundamental case, which is some piece of code and a script that installs it automatically. And if you think of those two things, that basically describes a Docker container for you. Now, there's other concepts that will take time to learn, like multi-stage builds and layer optimization, all these different things, which take time, but you can learn that stuff iteratively. And when you learn it, or even if you see an example of it, it becomes pretty obvious just by looking at it. The Docker file tutorial that's on docker.io, it's what I use to learn how to make Docker files. Maybe I have more experience and, it would seem more natural to me, but it takes 10 or 15 minutes to go through that tutorial. It's very, very simple. Pretty much any project on GitHub is going to have, it's going to have a Docker file element to it. And that just by looking at examples, you can learn a lot of stuff. I know on the Nimbix GitHub, we have tons of, probably about, I would say 50 or so projects on there that are Docker based. So that's just by looking at examples, you can learn that way. I guess project-based learning, I would think about it, I guess in the context of, should I get involved with a project to learn how to do stuff? Sure. I mean, open source projects are great. And by the way, if you look at what open source projects need, I wouldn't say almost never, but they rarely need more developers as their primary need. I would say documentation and testing and sort of issue resolution and things of that nature, testing especially, but documentation. You can get involved with a project where you learn how to use that project and you start documenting it, and you're contributing that back to the project, or you're testing it by actually learning. And by the way, when you test it, you discover bugs in the code, and sometimes you fix them by submitting pull requests. Other times you create issues and you make sure that you collect all the data. You're providing a really valuable service that way. So even if you don't think your development skills are necessarily what the project needs for new development, you can still get involved with the project. When it comes to Kubernetes itself, I'll be very honest with you. Kubernetes is really hard, and I don't mean to dissuade anyone from getting involved in Kubernetes, because it's really great. But it's really it's not hard to learn the basics, but it is hard to learn the nuances. You just have to have experience with it, and it takes time. There are also a lot of resources out there, and if you're willing to spend some money, there's a lot of training. There are courses, etc. But yeah, I would definitely, for those technologies, I would definitely look outside the universities. And like I said, the good news is most of the basic content is actually free. It's in fact all the basic content. And the Kubernetes documentation is actually pretty good. The problem is that it's probably not enough for a beginner to really grasp, but it's probably enough to get you started. And then from there, experience and just kind of learning by doing will get you the rest of the way.
Mm-hmm. I mean, you're completely right in the sense that this is an entire episode on its own, right? Now we have 2 reasons to bring you back on the show. But hopefully, Rishika, that was helpful and sort of helps you figure out more about how you can go about actually learning these technologies. Remember, at their core, things like Docker, for example, are pretty simple, right? You could just go to the Dockerfile tutorial on the Docker webpage and take a look at that. I gotta agree with you though, Leo, on the Kubernetes end of things. It is surprising, it's more difficult than it looks on the surface. I mean, for me, I was personally like, oh, I got to use Kubernetes for a project. I would be like, how hard could it be? And while the basics, you're right, are pretty simple to grasp, right? You get the immediate concepts, getting the nuances and how all the different pieces work with each other. That can be a little bit challenging for something as large as that project.
And it's a moving target.
Yes.
Which is it's good because as an experienced Kubernetes developer or user, it keeps you on your toes. You have to keep learning, but it's obviously bad because you have to keep learning in the sense that you don't just become an expert and then you're done. You have to look at there's constant change in Kubernetes. I'm not sure that'll ever fully stabilize, actually, given the kind of the Google flavor behind it. Google tends to innovate nonstop on pretty much all their products. And that includes, unfortunately, changing APIs pretty regularly. So it really kind of forces you to continue to learn, even when you've got a pretty good baseline of understanding. But it's the good news is that unless if you use Kubernetes through a technology like Jarvis, you don't have to interface with it directly. In fact, Jarvis doesn't actually let you do that. So if your purpose of using Kubernetes is just to run your algorithms, you don't have to use Kubernetes directly to do that. There are technologies like Jarvis that will let you do it, without that. If you're looking at building platform software that talks to the Kubernetes API or deploying Kubernetes, which by the way, those things are somewhat related. You still have to understand conceptually how things work on both ends, but being a Kubernetes sort of system administrator, if you want to say, cluster administrator versus being a Kubernetes developer are also very different things. Kubernetes has a very much has a concept to where the service provider just takes care of everything. And if you're the service provider, then that's you, right? But otherwise, if you go on, if you use Google's Kubernetes engine or use Azure, or use IBM's, whatever, and AWS, EKS, you don't have to worry about will the network work, right? Of course it'll work. because the provider is already ensuring that that's going to happen. You can really focus on how do I consume these resources. But if you're deploying it yourself, then yeah, you have a lot of work to do and learn. So.
Yeah, definitely. And it's going to keep changing. Google does have that habit of just continuously innovating. And a little while ago they'll switch over from TensorFlow 1 with their graph building approach to TensorFlow 2, and then suddenly now they've got a NumPy API, and there's just a lot of things happening really quickly out of seemingly nowhere.
Which is why you need containers to keep it all straight, right? That way your code doesn't have to change every single time. Yeah.
Tie it back in, we go full circle. That's nice. But yeah, no, this has been a really, really insightful discussion for me. I mean, there have been lots of really interesting questions from the live chat. Thank you everyone for actually sending those in. Now, one thing I do want to ask you, Leo, before we end today's discussion, and hopefully we have one more in the future as well, is do you have a closing message that you want to share with the audience today before we leave?
Yeah, I do, and it's kind of echoing like something that my mentor taught me a very long time ago, and it was kind of hard to hear as a young developer because you really just kind of want to innovate and do cool stuff. And the message is that deployment trumps functionality, in the sense that if I'm building a software product or project, let's call it a product, and I want to either sell it or give it away or something, if my customer or my end user can't actually get it deployed, then it's pretty much worthless. It doesn't matter what it actually does because they're never able to realize the value of it. So the way that ties into containers is that it forces you as a developer to think about your deployment strategy the entire time, because it's part of your container build is the actual deployment, which is effectively what the Docker file is. Mm-hmm. So it eliminates, so all you have to give the end user is a container address and maybe a very simple markdown on, run it with this parameter or that parameter or that parameter. But you don't have to worry about, writing an entire how-to, which I've seen some how-tos on installation that are like 30 or 40 pages long.
Yeah.
I mean, it's insane, right? Nothing should take that much effort to get working. Where if you look at the average on Docker Hub, the average markdown is like it's a paragraph, right? That just says, just pull the container, run this command and that command, and then you're done, right? Mm-hmm. So think about how the end user is going to consume. It doesn't matter how great your code is. If it can't be consumed, it has no value. It might as well not even exist. Yeah. Like, how do I know it even works if I can't get it to work, right? Mm-hmm. So really look to containers to help with that. But in general, think of deployment throughout the entire process of building any sort of product. And it's not the most glamorous thing, especially if you're into algorithms or cutting edge technology, but it has to be done in order for someone to be able to consume. So that would be my closing message.
Thank you. I mean, first of all, I love that message because too many times I have seen different open source projects or different, even just software generally, or that's given out to the community without any instructions or without at least clear and easy to use instructions as to this is how you can get started with actually working with this software. And I feel like that is such a disservice because you've made this incredible tool, something that can really change people's lives, and why can't we use it? Because we don't know how to install it, right? So I feel like that's really an important problem to solve, and the technologies that we've talked about through this discussion, I think, are really important and key to doing that, of course. All the way from containerization to even like how can we use like high performance compute environments within those actual containers, right? Helping data scientists, for example. And that's just the example that I'm using because that's the one that I'm most familiar with, but really everybody with all kinds of different use cases with the power of these containers by making it so that, as developers, we're almost in a way forced to not only think about, hey, this is how it's going to work on my machine, but, well, my machine is what is going to be shipped to everybody. So we got to make sure that my machine is clean, it's elegant, right?
And if I could add just one quick thing to my closing statement. Sorry, Definitely. It's like part two of my closing.
No worries.
If you think it's not, so we haven't really talked about the commercial space too much, and there's obviously a lot of, there's a lot of people that are going to do open source, a lot of people that are going to work for a company that does software and sells it. So software vendors, what we call ISVs. If you're selling your software or work for a company that sells software, think about the support team that company has to maintain, and think about what the number one sort of support ticket they get. And that ticket is, I can't get this installed. and it's in some flavor, right? So if you make the software distribution something that they just run, they don't have to install. Now I'm not advocating that we should strive to eliminate support jobs, because there's other support issues that need to be dealt with. But you've now allowed your customers to go high value from day one, and you're not burdening your support team with mundane stuff like, is it plugged in? The equivalent of that. So, and that's something that you're forced to do but forced in a good way. You're almost everybody has some sort of installation script. Most developers don't type the same commands 20 times.
Yeah.
They type them twice, and then the second time they type them into a script, right? So the point is, you have that installation script already. Just make it something that can plug in and that anybody can run, not just yourself. And oh, by the way, now make the Docker builder run it, and now the end user doesn't even have to run the installation script. It's done for them automatically when they run your container. So anyway, that's my part 2 closing statement.
No, I mean, I love that little statement there, because I feel like that's so meaningful, right? It's as a developer, we're being forced to do something extra, but in a way it's a good thing that we're being forced to do that, right? And I'm sure that most developers would be happy, because at the end of the day, it makes a developer's job easier, because now they don't need to, sit there and write out the documentation and
Right.
those 30, 40 pages of how do you install this thing, right? It's just, here's my environment, run a Docker build and a Docker run, right? It's pretty simple. And if you're using something like Nimbix Jarvis, you don't even need to do that.
Right.
So I feel like that's what is really interesting about this whole domain of technology. So I mean, thank you very much, Leo. This has been a really fun discussion. And it's been, I've learned a lot from it. Also, there is a comment on the live stream from Just Program saying, I think you should make a live stream answering viewers' questions. So really quickly, we did answer a couple questions during this live stream, so do feel free to go back there. But if you do want to ask me more questions, I have already held a special episode of TechLifeSkills on Ask Tanmay, so you get to ask me any questions you have, and there's another one coming up in January 2021, so make sure you are tuned in for that. So do join in for that. But again, thank you very much, Leo. I mean, I've learned a lot about the world of containers, and as a developer and as a machine learning developer, really, how they're really impacting me and enabling me to do better work. And I'm sure that everybody's definitely gained a lot of insight. So thanks for joining, and thank you to everybody on the live stream chat for joining in today as well. Of course, the TechLifeSkills series is held every Sunday in the morning Eastern time, so do make sure to join us next week. We're actually going to be covering something actually pretty nicely related to what Leo and I were talking about today, from less of a technical perspective and more of an enterprise perspective. So make sure you do join us then. It's going to be a really fun discussion. But once again, thank you very much, everybody, and goodbye.
Thank you, Tanmay. Bye-bye.